to my channel. So in this video, you're going to cover the system design question called design the food delivery system. So there are some popular apps on the market like UberEats, DoorDash, just to give you an example. So before you start the real content for today, I would really appreciate that if you can help subscribe to the channel because it can help it grow. So thanks a lot. So let's get started. Design food delivery system. In a system design interview, usually you start with scoping. So in this part, you're going to ask the interviewer some questions, and at the end, you are going to have some solid feature requests defined here, and also you're going to clarify the non-goals that are not going to be covered in this system design interview. Because this question is rather broad, so we definitely need to ask some questions to understand what we are trying to design. So actually, I think there are three types of users for this kind of app. So one is a restaurant owner, so who is going to make the food, and the other one I can think about is a driver. It's a delivery guy who is going to deliver the food from the restaurant owner to the customer. And the third type of the user is the customer who is going to use the app to order some food from some restaurants. So the first question is, what is a target? I will say for the three types of the users, there will be three different types of the versions of the app. So let's say we are only going to cover the normal customer, which are people who order food within this app. So we don't need to worry about like restaurant owner trying to register their restaurants, or the delivery guy who get a notification and update the order status, something like that. We don't need to worry about that. So and the other thing I want to ask is are we going to focus on the UI UX, mobile app design, etc.? So let's say we are not going to cover that UI UX front end stuff. So instead we are only going to cover the backend service part. So only focus on backend service. So there's some other feature requests I would say. The first thing I can think about, like as a normal customer, when I open the app, I need to do some authentication, authorization stuff. Let's say we don't need to really cover that. So no need to cover the authentication, authorization stuff. And so after user login, so based on the current location of the customer, you're going to show a list of the restaurants nearby. So the feature request would be, I think one feature request is to show the nearby restaurants. But we still need to make this one a bit more solid, a bit more specific. So how do we define the nearby restaurants? So are we going to show the restaurants within the 20 miles radius? Let's say we are only going to show the restaurants within 20 miles radius. And what would be the other thing is, how are we going to rank the restaurants? Let's say we are not going to do some fancy recommendation based on user interest. Let's say we are only going to sort by distance. So there could be some fancy algorithm like computing the similarity between the restaurant and the user, and then do some recommendation, and further use the score to rank the restaurants based on the user's interests. So let's say we want to simplify the question, just sort by. We just show the restaurants within 20 miles radius and sort by the distance. So the other thing is So suppose one user choose a restaurant, type on the restaurant on the mobile app, then we are going to show the list of the cuisine from the restaurant, then other food. So the other feature request I can think about is to order food in the app. And then after the order, let's say user could potentially cancel the order. Let's say, are we going to support the cancel? Let's say we also support cancel order. And the next thing I can think about is after we place the order, then user should receive some notification. Let's say a notification is also covered within this system design question. And another thing I can think about is after the food is being prepared and when it is picked up by the delivery guy, are we going to show the status of the delivery? Let's say where the delivery guy currently is. So since we have quite some feature requests here, let's say we just put this one as a non-go currently. But if you have time, we can still cover this part. This is like a real-time delivery status. So this one actually is not it's not hard, so you just need to use the Google Maps API to do this. But let's say we just put this as a non-go here. So currently we have pretty good feature request defined here, so we are only going to focus on the backend service part and only going to cover the normal customers and show the nearby restaurants, order food, cancel order, and send notification, etc. Okay, so that's pretty much about this part. The next part is about doing some constraints analysis. So this part, it can help us to understand what is the scale of the system and what are the SLOs for this system design. So the first thing I want to think about is the traffic analysis. So let's say we have 100 million daily active users, so that's quite a lot. So each daily active user is going to give us, okay, so I think I forgot to ask one question. Is this in this app only for US customers, or is it international? Is it going to cover like the people from like APSC or Europe, etc. So let's say this one is only US based. This is no internationalization. We don't need to care about that. Let's only target the US customers. So let's say we have 100 million daily active users in the US. So each user is going to give one request per day let's say one request per day for everything, for like the other food, for show nearby restaurants, something like that. Let's say just this is just a very rough estimation about the traffic. Let's don't tell which kind of request the user is sending. Let's say just one request per day. Just take a look at the traffic. So 100 million, let's say 100 million daily active user, one request per day, which means 10 to the power of, this is 8, okay, divided by 3,600 3,600 seconds per hour and 24 hours. So let's say this would be, so this one is, let's say this 1,000, 10,000, 100,000, which is 10 to the power of 5. So this means we have 1k kps. But usually people order the food during the lunchtime or during dinner time, or sometimes during breakfast time. So this makes the traffic to be very spiky. So let's assume that for the peak time the traffic could be anywhere around 5k kps. So we have, let's say we target about 5k QPS. It's not that large. So normally for a normal server, you can handle like 1k QPS very easily. But it really depends on the the how expensive the query is. So this one, traffic analysis. Another thing we need to do is storage analysis. What is the storage? How much of the space we will need to store everything. So let's say we have 100 million daily active users. So we have the user to be stored in our database, but 100 daily active users is not a very big deal. So the most part is actually the other history stuff. So for the for the other, we have 100 million others, which is 10 to the power of 8. Let's say 365 days per year, and then let's target for the 10 years. Then we have, and then let's say each other we are going to have not too much, let's say 1k to store that. So actually we should need less than 1k, because each other we just need when we store some proto buffer for the others, it should take less than 10k. It should be less than 1k. So for this one, let's say it is 1k per other. So let's say 100. So okay, so 10 to the power of 8, which means 0.1 gigabytes. So this is 0.1 gigabytes. So 0.1, this means times 10, this is 1 gigabytes. 1 gigabytes, this is 1 TB. So it's something like 3650 TB for the next 10 years. So around 300 TB, something like that. So it's let's say it's just 400 TB. So pretty much something like this. So it means we need to use NetSQL for this. Because using SQL SQL is quite hard to scale when there is a large volume of data. So yeah, so we will need to use some NetSQL to store the other history stuff. So the other thing I can think about is for example the availability. So let's say the downtime is let's say 99.9 availability, which means for every year maybe several minutes for the downtime. And consistency, so let's say we only target for eventual consistency. It's not so it's not like okay, so let's say we target for eventual consistency, then it means you can have some master slave storage infrastructure setup. But sometimes, like for example, when people view other history, when a query is some replica and the replica doesn't have the up-to-date data, then it can show some laxing. But eventually you should be able to have the right data to be shown to the user. So let's say this is eventual consistency. But usually I would say it is very quick regarding the sync between master and slaves. But let's say we target for eventual consistency here, and durability. Let's say we are not going to lose data here. And also scalability. Let's say we are currently targeting 100 million daily active users, and we are trying to build a scalable system, and it's robust enough to handle like a peak traffic. So I think currently durability, scalability. So I think that's mostly that for this part. Okay, so scoping constraints analysis. The next part is about general design. To design some general infrastructure and understand what are the components we are trying to have, the data flow between the different components, but we are never going to dive too much into the detail. So this is general design, which is high level thing. Yeah, so let's say I'm a user. I'm just a normal customer who is going to order food from the app. So I'm going to send the HTTP request to the server. Before that, we get the IP address from DNS. Then we hit the load balancer. The load balancer. After that, we are going to hit the front end server, or web server, or app server, depending on how you say that. So then we are going to further send some RPC requests to the backend server, and then the backend server is going to do some manipulation, maybe query, get data, or write data exactors on top of the database. But usually on top of the database there is a cache layer. So that's mostly the general traffic, a very, very high level design about the system. So let's say how we fulfill, what are the components we are going to have to fulfill the different feature requests. So let's say okay, so first one, okay, only going to cover normal customers. That's fine. So we only cover this, the normal customer in this general infrastructure. Only backend service and the show nearby restaurants. Okay, so for the show nearby restaurants, you should have a service called the nearby restaurant. Nearby restaurant service. So nearby restaurant. Show nearby restaurant. So this service, we are going to send. So let's say, so usually when users send HTTP request to a balancer, then to front end server, and then the front end server is going to send RPC requests. Let's say we use portal buffer to send the request to the backend server, and then we also get the portal buffer response from the backend server. So let's say the request, it should contain, so it should contain the current user location. Let's say lat long. So we should have the user lat long included, and also we should have. So currently we are going to show the 20 miles radius just sorted by distance. Let's say sometimes we can change the radius a bit. Let's say it is a radius. So the response is going to be a list of the restaurant ID. And also we are going to have a service which is restaurant, let's say restaurant detail service. So the restaurant detail service, for the request, we are going to send the restaurant ID, and then response is going to get a list of the details about like the restaurant name. Let's just call it restaurant details, or restaurant info. So the restaurant info maybe name, cuisine, like what type, if it is Chinese restaurant, if it is American restaurant, Indian food, Korean food, etc. So so this one, so when a user initiates a request to our service, so we are going to call the backend service. So first of all, we call show nearby restaurant. So based on the user lat long and the radius, we are going to return a list of the restaurant ID, and then we are going to call the send a batch request which contains a list of the restaurant IDs. Actually, this is a list of restaurant ID and the list of the restaurant info. So you're going to return the list of the restaurant ID. And then response is the list of the restaurant info, and then you're going to further do the computation between the restaurants lat long and the user lat long, and then we are going to sort by distance and return the response to our user. Okay, so let's say here actually it says that we're having the user lat long radius, then we return list of the restaurant ID. Yeah. So actually, let's define it on a high level. Let's say we are going to return the restaurants info, a list of the restaurant info. So in here, the show nearby restaurant, first it's going to get the list of the restaurant ID, then based on the restaurant ID, it is going to call the restaurant detail service to return the list of the restaurant info. So something like that. So this service is going to depend on the restaurant detail service. So this is a component for the show nearby restaurants, and the other one is order food in app. So in here, we are going to first let's define another service. So when a customer type on a restaurant, then we are going to call the restaurant detail service, and then send a request. So the request is only going to contain one restaurant ID, and the response is going to be exactly one restaurant info, and to be shown to the customer. So then the customer can further see the cuisine and then make a couple others. Let's say other food service. So let's say we have the other service. So the request would be so let's say the request would be, it would contain the restaurant ID, of course, and also it should contain the cuisine, a list of the cuisine ID, and then the response. So what will be the response? So the response would be the status, whether it is successful or not. So let's say, suppose I'm a customer. I add a list of the cuisines into my cart, and then we send the request to our service. Our service is going to call some third-party service to collect the money from the bank, and then we are going to store the other info into our database, and also we are going to send the response, and at the same time we are going to send some notification. We are going to call us. Okay, so let's say we have a notification service. So the notification service is going to it is going to send the notification to different people. Let's say I order some food, and I send the request to the other food service. The other food service is going to store the other information to our database, and at the same time it's going to send the notification to the customer to show if it is successful, and also to the restaurant owner to say, okay, hey, you have a new order. Alright, so that's the order food. And the other thing is cancel order. So the other thing, let's say cancel service. So the cancel service is going to send the order ID to, let's say we have the order request, it's order ID, maybe status all order ID, something like that. Yes. So the response is So if it is a private buffer, then actually it should have the other ID as optional field, and also the status. Let's say this one. So for the cancel service, the request should be the other ID, and the response is a status to show if it is successfully canceled or not. And that's pretty much it about the different components we have here. So yeah, we define different components: the show nearby restaurants, restaurant detail, notification, order food, cancel service, something like that. So that's pretty much it about the about the general design. So depending on the interviewer's interest, you may need to dive into different parts to see how we are going to design the thing. So let's detail design. So let's go over each part in detail, so that we cover pretty much everything, and then it can help you to understand the whole system, and also maybe helpful for the interview stuff. So okay, so where should we start? So for the notification service, which is a quite I think that one is a quite straightforward thing. So we actually have a separate video covering how we design the notification service. But essentially, it is something like we send the request to the notification service. Let's see how to call it. So let's say we have we have different types of the notification source. So let's say we send some RPC request to the notification service. Service. So essentially, it is going to try to query the DB about the notification setup. So let's say this is a notification service. Yeah, so this is notification service. So we just start from some simple stuff to some more complex stuff. So first of all, it is going to query the database, but on top of that, usually there is a cache layer sitting on top of it. So what are we trying to query here? So we are trying to query the notification setup about the user, or about different stuff. So for example, let's say we send the food delivery. So let's say the food is picked up by the delivery guy. Then we will need to send a notification to the customer who ordered the food. So essentially, the system, internal system, is going to send a request to the notification service, including everything, including the notification message, and then we are going to try to query the notification settings for the food order, for the customer who ordered the food. And then, for example, some email address, or like the phone number, or the ID of the phone, etc. Then it is going to put the notification message into different queues. Let's say we have a queue for the phone. So we have different queues here. So just use let's say the phone queue. This is message queue for phone, and for example, message queue for SMS, message queue for mobile. Let's say we have different queues for iOS and for Android. or maybe we can just save it here. Let's say we have the message queue for the mobile, something like. So essentially, we have different queues for different types of the notification, and then we call this. We have for each of the queue we have the corresponding workers to consume this, to consume the message within the queue. And then different workers to consume the queue, and then the worker is going to call the third-party service to actually send a notification. So for example, for phone, do we really have some phone call? Actually, I don't think so. So let's say usually it is just an SMS here. So it is SMS and email and the mobile stuff. Okay, so the worker is going to call the third-party service to deliver the notification. So that's essentially how the notification service works. And also at the same time, I think the notification can also store the notification history, but that's not required here. Usually you just query the database about the setting, that's it. So the next part, let's say the show nearby restaurant, how we are going to design this one. So this one you will need to have some knowledge about some geo-indexing, some normal ways about geo-indexing. But that's you don't need to worry too much about it if you don't have the corresponding background about that. So usually for the restaurant will have the corresponding lat long, and the user has the corresponding lat long. So how are we going to show the nearby restaurants? Of course, we cannot do a whole DB scan to compute the distance. That would be a horrible stuff. So what we need to do is we need to use some normal ways to do geo-indexing. So glad we already have the Google S2 library, which is supported for this use case. But I would essentially tell you how geo-indexing is working. So there are several different ways. So for example, the geohashing, the quad tree, or another way which is quite commonly used, R tree. So all those three ways are used very commonly in geoindexing. So I actually have another video for finding POI stuff. I actually have another video for finding POI, finding point of interest. So in case you have interest, feel free to take a look at another video. But I'm going to briefly go over how it works. Usually, let's say for the surface of the Earth, we divide this. Let's say we divide this into a 1 mile by 1 mile grid, and then we further index the grade, and then based on the grade ID, we are going to be able to find the nearby grades. So after finding the nearby grades, then so first of all, based on the lat long, we find the corresponding grade ID we are currently at, and based on the indexing, we are going to be able to find the nearby grades, and then for each little grade, it will contain a list of the restaurant ID. So we get the list of the restaurant ID from the nearby grades and from the current grade. Then we are going to do the computation between all the restaurants within the nearby grades and within the current grade, and then further do the computation on a subset of the restaurants we have here. So that's mostly about finding the nearby restaurants. So it's mostly based on the geo-indexing stuff. So the next one, but if it is a normal interview, people may ask you to further specify how this works. So maybe I can dive a bit more detail here. So so those are different ways, but like say geohashing can just display the whole map into some polygon. Let's say to split it into some 1 mile by 1 mile grid. An R tree actually can be better than this because, for example, for some suburb area there really isn't too many of the restaurant, but for some metropolitan stuff, for some downtown area, there are a lot of restaurants. So the R tree is trying to make sure that for the nose, for the leaf nose, it should have a balanced number of the restaurant ID there. So let's say for a suburb area, the grade can be large. Let's say it's 10 mile by 10 mile because there isn't too many of the restaurant. But for the downtown area, the grade can be, let's say, maybe 0.5 mile by 0.5 mile. So the archery so the archery is going to have it's not going to have uh, like uh, like the fixed size of the grade, but it is going to it's going to change the size of the grade based on the number of the number of the restaurant IDs contained in the node. So but all the three ways are used very often in different geoindexing database. So we have the show nearby restaurant stuff. So first of all, we have the grade ID, and then nearby grade, then list of the restaurant ID within the grades, and then based on the grade ID, we are going to call the restaurant detail service. Based on the restaurant ID, you're going to have the restaurant info, for example, the name, to be shown as a list. Let's say the next one I would want to talk about is the restaurant detail service. So this would be a very straightforward thing. So the restaurant detail service. So I haven't asked about how many of the restaurants are there. So let's say we have 10 million restaurants here. So this is a very small size of the restaurant, so it will be easily fit in in memory. So we are going to we are going to store the database, store the restaurants in the database. So based on the volume, I think we can use RDBMS for this one. But if you want to store the other history for the restaurant, we want to store the restaurant info and also the restaurant other history together. We can also use some non-SQL like Bigtable to store everything together. So but that's not what we are going to that's not what we need to worry about here, because we only cover the normal customers. So for the restaurant detail service, essentially what we are going to do is we are going to store the rest. So let me maybe draw something here. So this is restaurant detail service. So it is going to we are going to store all the details, all the restaurant details, the key value pair in the cache. So let's say we use memcached here, and the cache is based on the DB. So the DB, as I said, we could use non-SQL, we could use RDBMS, depending on further needs here. So the restaurant detail service is going to essentially, based on the restaurant ID, we are going to get the corresponding restaurant info from it. So it's very straightforward, not need to worry too much about it. And because we store everything in the cache, so this would be a very fast service here. So let's say the next part, the outer foot service. So the outer foot service, I think that's the most juicy part here. So we are going to cover like the database design here and etc. So the outer foot service, let's say we are going to send the request including the restaurant ID, a list of the cuisine ID, and then we are going to update the database and also call the third-party service for payment. Third-party service for payment. So the DB part, let's say so first of all, what kind of DB are we going to use, and what kind of data schema is that? So for the DB, it's mostly about the order history. So we actually have two things. One is the user thing, and the other one is pure order history. So for DB, which kind of database? Let's say we use NoSQL for both of them. So you may argue that we could use RDBMS for user, but actually you may understand why I use RDBMS for user as well here. So for user ID, for the user, let's say for the NoSQL here, you just use bake table here. And for user, we have different. So the row key, of course, it is a user ID. Row key is user ID. So if you want to ask how we generate the user ID, we could make use of like UID to generate unique ID, or we can have a unique ID service, which is quite simple for us. So if you wonder how to build a unique ID service, so the unique ID service is quite simple. So usually we can have three things: the timestamp, and as the first part, the second part as the data center ID, the third part as the server ID, and the last part to dedupe. Suppose a request is sent at the exact timestamp, exactly the same data center, exact server, then you can use the REST ID for deduping. So you can generate 64 bits of the unique ID here. Yeah, so let's say we don't need to worry too much about the ID here, ID stuff. So for the row key, we have the user ID and the column. Okay, let's make it a bit. So the column family. So the column family, let's say we have the info stuff. So the info stuff is going to so it is going to contain so column family is going to, okay, so the first column family is the info. So it is going to store the proto buffer about defining like the user profile, like the username, like the name, email address, like the notification setting, etc. So that's the first column family. And another column family I would have is the order history. Order history. So this one, let's say we have. Actually, you just need to store the order ID for the order ID. But to make it more extendable, let's say we have a proto defined here. First of all, let's say we have the order ID stuff. But in the future, you can add more things more things if we need to say. Let's say we need to do some recommendation stuff. Maybe we need to add some more stuff here. Or maybe you want to expedite this a little bit. We may include the restaurant ID, etc. So for the user is something like that. For the order history, what you're going to have is the row key, of course, is the order ID. So order ID is also generated from the unique ID service. And for the column family, we are going to have a info. Let's say the info is defined as a proto buffer as well. So the other info can contain the restaurant ID, cuisine ID. So yeah, so we can have the restaurant ID, cuisine ID, etc. So I'm thinking about if we need to include the other status here. So if we include the other status here, so there are two choices here. So one is we have another column family about the other status. So if we do this, I think it's okay. And if we just include the other status into the other info stuff, I think it's also okay. So let's say we have the other status as a different column family here. So it is going to be something like a proto which contains the enum about the status. So the enum could be like, say, other initiated, preparing, and also picked up, and also let's say delivered, and maybe another thing is canceled, something like that. Yeah, so I think, so this is pretty much about that schema. So for the other food service, we are going to first update the DB about okay, so and there is some notification service service. So we are going to insert a entry into our other history stuff. So this one, and also at the same time, we are going to insert another entry into the corresponding into our user table for the corresponding user ID, and update. It's not like update. It is going to insert an entry, a new column, a new cell for the other. For the new order. So in the other history part, we have the other ID created, we have the other ID of the row key, and we include all the other info. And we initially we set the other, we should set the status as other initiated. So on the restaurant part, so we are going to call the notification service at the same time. So once we call notification service and the notification is sent to the restaurant owner, so the restaurant owner will see that. So and the restaurant owner is going to open their version of the app and change the status of the order to be prepared. And then once the driver, once it is prepared, we are going to I think we are not covering the other services here, but essentially once the order is being prepared or or it's ready to be picked up, then during this time you're going to find a nearby driver. So by finding the nearby driver, you could use Google S2 library to find the nearby drivers, and then send the notification to the driver. So the driver is going to open their version of the app and then can confirm to pick up the order and then change the order status to be picked up. And then after that, once the driver pick up and on the way, and then finally send deliver the order to the customer who ordered the food, then the status is going to be changed to delivered. So this is it's like we are going to update the entry by three different parties: the restaurant, the customer who ordered food, the restaurant owner, and also the driver. So let's say another thing is the cancel. It's the order cancellation. So the order cancellation, that one we have like a cancel service. So here, so let's say the for the order cancel service. Let's say we cannot really cancel the service once the food is being prepared. So we can only cancel the service when it is order initiated here. But yes. Let's see. So it is quite, so regarding the logic, I think it's quite simple, because like request is just the order ID and the response is the status. We're just going to we are just going to update the database, which has the order. It's not order history, it's just order. So we are just going to update the corresponding entry in the order table to mark the order status as cancelled. But before that, we need to call. We need to get the order status for this order. So once it is changed to prepare, we cannot really cancel that. So it depends on the business requirement. So essentially, if the order is initiated, we cannot cancel it, or maybe we can just simply cancel that regardless of the status. So it really depends. So we may need to ask the interviewer about this question: how we decide whether the order is cancelable or not. But we get the idea about how to do it. So it's essentially update the database. But when I think about updating the database, it makes me, yeah, so it makes me feel, if we have like the master slave stuff, and then the rate, so it can introduce some risk conditions. So for example, we have already changed the order to be prepared, and let's say we read from a replica which says the order initiated, because we only have the eventual consistency here. They can introduce some race condition. So what I'm thinking is we could use some master. We can have the different replica as master, but still for each of the big table that center, so it can be, yeah, it can still have something. Let's say if we have master slave, I think it's going to cause some risk condition. So if we have everything as master, I think that one is going to be fine. But well, yeah, so we need to understand when we do the query whether we are trying to query the thing which is low watermark, whether it is high watermark. So high watermark is means that the replica or the replica that has the most up-to-date information, and then the low watermark means that what every of the replica have which is the replica that has the oldest one. So I think we need to read the high watermark of that. So regardless whether we use master or master slave, So let's say we are reading the high watermark stuff, which is the 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 most up to date other status. Then I think we should be able to find that. Another or otherwise we can use some lock and introduce some lock to lock the row when we do the raid. So instead of making it to be yeah, like we need to first lock the row, not to update it, and then we read the thing which is high watermark, and then based on the current status we decide whether the other is cancelable or not. Yeah, so I think that in that way we should be able to make it we should be able to make it to tell whether the other is cancelable or not. Yes, but that's pretty much it about the cancel service. We should, yeah, I think we don't have any issue here. So we have, let's say what we have missing here. So we have the notification service, show nearby restaurants, restaurant detail service, order the food. So order food, most Jersey part is about the database and how we update the database, and the cancel service. So overall, I think we have most of it. Yes, I think that's mostly it. So if you have any other questions, feel free to leave some comments below. If you like this video, please help subscribe the channel. This is the end of this video, so I hope you enjoy it. And yeah, if you like this one, please help subscribe this channel. I'll see you next time. Thanks for watching.